Hey guys, and welcome back to another episode, I guess I could call it, lesson, class, whatever, on the 220-1201 A+, Common 1 exam, where I'm going to tell you everything you need to know about the exam objective right in front of you. I'm going to tell you the kind of questions you might be asked on your exam, and I'm going to give you some practice questions at the end of the video to make sure that you can tell whether or not you're ready to tackle this exam objective for the real thing. So let's go ahead, get straight into it. We're going to go through all of this today, so let's go ahead and get a start. We're talking about ports and protocols today. Let's try to underline that properly. Ports and protocols today. If you don't know what that means, that's okay. We're going to go through it. So look, like I said, ports and protocols. Before we get to the notes, let's just go over the rough topic. What does that mean? So we're going to use a little metaphor here. Pretend you've got two houses, right? Each house represents a computer, and you can choose to enter this house in any way, shape, or form, right? So, you could go in the, let me just change my color of my marker here. You could go in the front door here. You could go in this window. And furthermore, you could potentially send something from this window. Maybe you want to throw a paper airplane, and you might particularly try to aim for this window here because that's the person you want to communicate. So each building represents a computer. Now, the door, the window, and each window, each way of entry essentially represents a port on your computer. So hopefully we've got that so far, right? The house represents a computer, the door, the window represents a port. They're at the same house, they're at the same address. They're just a particular way of entering. And we're going to take it one step further. Within each of these ports, so let's zoom into this particular window. Let's say we've got this window here, or this port, and within this window, we have a person. Bob lives inside this window. If anyone wants to reach Bob, they have to throw from their computer, they have to throw their data all the way through that particular window because everybody knows that Bob lives in that window, all right? In this instance, what this is representing in this little metaphor here is that every port is typically associated with a particular protocol. Ports particularly do a specific thing in general, right? So just as an example, this might be port 1. This window is port 1, and port 1 is where Bob lives, right? Just as an example. So keep that in mind as we move forward. That should hopefully clear things up a little bit as we continue to move through this exam objective and talk about the different ports and protocols. So what this looks like in real life, right? I got this picture from Wikimedia Commons, which is free licensing, so Wikimedia Commons. I've referenced you there. Please don't take this video down. So basically, in real life, what this would look like would be you'll learn more about this kind of stuff. A program called Nmap when you get to your Security Plus certification. But basically, you might decide you want to have a look at another computer and you want to see what ports are open, because depending on what ports are open, that's going to determine your potential method of entry. So you might scan another computer and you might see, okay, port 22 is open, port 25 is open, port 80 is open. And on each of these ports, so port 22, for example, on port 22, it is running a service or a protocol called SSH. So that port is open and it is running that service. So I could potentially try to get into that computer using that service. Or port 25 is open and that is running a service called SMTP. I could potentially try to access a computer through there, just as an example, right? So in the same way that you might look at a house with the windows, you might say, oh, I've scanned this house and I've noticed that this window right here, the little latch is unlocked. So I can try to open that latch and get in that way. The same way you would have a look at the port and you could say, okay, that port is running a program and it's actually open, so I can get in there, right? That's a very security focused way of looking at it, but that's roughly a brief explanation of ports and protocols, right? That's roughly what that means. So with that knowledge, let's go ahead and take a look at our ports and protocols that we're going to be looking at for this exam objective, the ones that we need to know about for our exam. Okay, so the first one is on port 20 and 21. So it uses 2 ports, and this one is called File Transfer Protocol, or FTP. Now, intuitively, before we even get into it, you can probably tell what this is used for, right? You can probably tell this is used for transferring files, and you would be 100% correct, okay? So port 2021 is File Transfer Protocol. It is used for transferring files between a client and a server over a network. Port 20 is used for data transfer, while port 21 is used for control commands, all right? Really, you just need to remember 2021 is File Transfer Protocol, and it uses those 2 ports. One is for the data transfer, one is for control commands, all right? The next one is on port 22. Now this is Secure Shell, or SSH, okay? So what this is, essentially, it's when you use the command prompt, right? So I've kind of simplified it down because you really just need to understand the concept. You're using the command prompt, and you're basically saying, you're communicating with another device through the command prompt, and it's in a secure way. So it's in a way where if anyone else is listening into this, they are not going to see the information or the data that you're sending. So if you wanted to log in to a different device over the command prompt, you would generally want to use SSH, right? So I've said, hello, I'm going to use SSH to transfer secure data to you. It is a secure method of communicating over the command prompt. That's basically what you need to understand for that. Direct comparison to the next one, which is on port 23, that is Telnet. So this one is an older protocol used for remote command line login, similar to SSH, but it's not secure because it transmits data, including passwords, in plain text. So that means, we're doing roughly the same thing, but instead, we're just hoping that these hackers or these people don't look at our passwords, because they can read everything that we're sending. Anyone can read what we're sending. So it is an inherently insecure protocol to use. And we generally want to avoid using Telnet if we're sending any data that is important. And really, probably don't. There's really no need to use it, to be honest. So look, if you're using Telnet, you may as well be saying, hello hackers, please don't read my password. It is 123456. Right? Yeah, you should probably use Secure Shell instead. It's more secure. It has the word secure in the name. Just use that. Okay. 25, Simple Mail Transfer Protocol, or SMTP. You'll need to know all of these abbreviations, guys. You'll need to know all of them. Okay. So Simple Mail Transfer Protocol is essentially used, long story short, to send mail between servers, right? So if you are sending mail, you're using SMTP. And an easy way to remember this is simply thinking of it as send mail to people. Send mail to people. Or another way to potentially remember it is TP. If you're going to TP someone's house, which is when you grab a roll of toilet paper, right, and you throw it over the house, you're not catching the toilet paper, you're throwing it. You're sending the toilet paper, right? But probably a more intuitive way is just send mail to people. Right? You can't get that wrong. There are 3 email protocols you'll need to know about. SMTP is the only one that sends the mail. The other 2 receive the mail. So just remember, send mail to people, or it starts with an S, that means send. S for send, right? That's another way to remember it. Okay, the next one is Domain Name System, or DNS. Again, you'll need to remember the abbreviation. So what this does is it translates domain names into IP addresses, allowing users to access websites using readable names instead of numeric IP addresses. So for example, if you wanted to go to journeytocipher.com, if we didn't have DNS, we would have to type in 169.11.2, right? That we'd have to type in the IP address. Okay, so what DNS does is it essentially, I'm going to try to draw it over here. It essentially takes an IP address, like instead of 1.1.1.1, it translates that into an actual word. So can I draw this with the mouse? Journey, you get the picture. Journey.com com. I'm trying to draw with my mouse, but I promise my writing's neater with a pen, right? So it translates the IP address into a name that is readable. So when we type in journey.com, journey2cyber.com, if you want to grab my learning guide, of course, subtle plug, the computer sees it and it says, oh, okay, that equals 1.1.1.1. That is the IP address. So I need to actually look for this. But on the human side, all we need to worry about is we're typing in journey2cyber.com. All right, so that is what DNS does. The next one, port 67 and 68, DNS, that is on port 53. You need to know the port number for all of these. Port 67/68 is Dynamic Host Configuration Protocol, or DHCP. So this is the protocol that assigns IP addresses to devices on a network automatically. So what that means is when you connect to a network, right, you're basically connecting and you're saying, hello, I'm new to your network. I need an IP address. Okay, so you're here, right? Hello, I'm new. This magical DHCP server is up here. It's a shining beam of light and it says, yes, I have an IP address for you. I can help you out, right? I can help you with that. Here it is. I'm going to give that to you. Okay, and then you say, wow, thank you. I am so happy. Now I can function on this network. The DHCP is what does that. Okay, DHCP server is what allows you to do that. We'll go into more specifics as to the exact way that occurs in upcoming exam objectives, but for now, just understand DHCP gives out IP addresses. It uses port 67 for configuration information, and port 68 is used by the client to receive it. All right, so that's what we need to know. Port 80 is Hypertext Transfer Protocol, or HTTP. Basically, that's using the internet, and it's using the internet in an insecure way. So if you need to send a password or login details or payments, you don't want to use this. This is insecure. Okay, there's a secure one that we'll talk about soon, but I'm doing it in order of the exam objectives. The next one is port 110, which is Post Office Protocol 3, or POP3. Now, this one is a mail protocol used to receive mail, right? So remember the other one, SMTP, was to send. This one is used to receive. Now, here's the thing. POP3 does not synchronize mail. So what that means is if you use POP3 to download an email, for example, or take an email onto your device, and then you go to use that same email service on a different device, you are not going to have access to that because it's not synchronized. Okay, there is one that does synchronize the mail service. There's one that does synchronize it. That's the key difference between this POP3 and the other one we'll look at coming up, which we'll talk about shortly. The next one is port 137 to 139, which is NetBIOS, or Network Basic Input/Output System. Now, look, there's a lot of words here. Basically, what you need to know is NetBIOS uses 137 to 139, and what this does is it provides network communication services on local area networks. So ports 137 to 139 are used for various NetBIOS functions, such as name resolution and data sharing. So it is, excuse me, it is providing network communication services on local area networks. All right, so if they mention anything about that in your exam, you know that's NetBIOS, and it's on 137 to 139. All right, now port 143 is the other email protocol that receives mail, but this is the one that synchronizes it. So this is really probably the one, if you want to synchronize your mail, you're going to want to use IMAP to receive it, right? So it is called Internet Mail Access Protocol, or IMAP. So this, you can read that if you want, right? But long story short, this is the one that synchronizes your mail. You use this to receive mail and synchronize that mail so that no matter what device you use, you have access to that mail, right? Your mail inbox is going to update, synchronized across all devices, okay? So, yes, that is it. Now, so long as you understand that basic topic, right? Pause and read it if you want to, but that's a basic concept, that you need to understand. The other one that we looked at, POP3, does not synchronize. It actually downloads the emails and removes them from the server, whereas IMAP does not download them. It synchronizes across devices. Okay, so everything is synchronized. All right, that's the key difference between the two. So if you want to receive emails and not have them synchronized for whatever reason, then POP3, but you probably want them synchronized, so you'd want to use IMAP. The next one is port 389, which is lightweight directory. So that is used for accessing and managing directory services such as user and resource information in a network. So if you're in a network and you need to access user and resource information, you want to use a directory service in the network, you're probably going to be using port 389 lightweight directory protocol. Okay, that's what you're going to want to be using. I know there's a lot here, guys. Unfortunately, we do need to know all this, but we just need to do roughly what it does and what port it's on. Okay, we don't need to really dive too much more in depth in that for this exam. It's very surface level, but we do need to know all this. I know it's a bit of a pain in the butt. Next one, 443. This is Hypertext Transfer Protocol Secure, or HTTPS. Remember how I said port 80 is for accessing the internet in an insecure way? Port 443 is for accessing the internet in a secure way. So if you're going to do a payment or password, login, anything like that, you want to use port 443 to access the internet over HTTPS. Okay, 80 is HTTP, 443 is HTTPS. One is secure, one is not. All right, it typically uses encryption methods such as SSL or TLS. You don't need to really specifically know what they are. You just need to know that it is a secure method of accessing the internet. Next one. Port 445, we're almost there, guys. Second last one, server message block, or SMB, right? So basically, this one is used for accessing and managing directory services, such as user and resource information in a network, specifically generally in a Windows network as well, okay? In a Windows network, you are accessing and managing directory services, that is SMB, server message block, over port 445, okay? So that is what you need to know. And finally, we've got the last one, port 3389, which is Remote Desktop Protocol, or RDP. And this essentially allows you to access someone else's computer remotely. If you wanted to access your grandma's computer remotely and take control of her desktop, you would use port 3389 using protocol RDP to do that. All right. So that, as it says here, remote administration and support. If you need to log into someone's desktop and help them out by taking control of the desktop, you would use this port. So I've done this little table for you guys. Basically, you need to know this table off the absolute top of your head. There should be, if someone comes up to you randomly on the street and says, draw this table out from heart, you should be able to do this. If there is any table you need to know for your exam, this is the one. All right, this is the one. So with that being said, we'll move on to the next dot point, which is just differentiating between TCP versus UDP. So these are two different transport layer protocols. In essence, they're two different ways of sending data. And I'm going to briefly go over them. I'll just take us away from the notes for a second. You've got TCP, and then you've got UDP. Pretend we have like a bunch of boxes here, right? Let's say I got a box over here, I've got a box over here, and I'm trying to get them to land in this spot, but there's a wall in the middle. I'm trying to throw them over the wall. What TCP does, right? Let's say I've got my friend here. My friend is here, he's called Hamish, right? Hamish, if he's operating under TCP, while he's throwing these boxes over to, I don't know, we'll call this guy Jenkins for some reason, Hamish is going to throw this box, and what he'll do is he will throw this box over. But the thing is, right, he can't actually see whether or not the box has landed. Maybe it broke, maybe it got lost in transport, maybe an alien kidnapped it and took it up to outer space, right? He doesn't know. So what he is going to do is he is actually going to ask his friend Jamish, hey, Jamish, before I send the next box, did you receive that box? At which point Jamish will say, you know what? Yes, I did. Please send the next one. I have received that box. So that's what's known as a connection-based protocol, right? So it's basically forming a connection. They're both communicating with each other, and they're clarifying whether the data has been received or not. Whereas with UDP, what happens instead is well, I'll try to use the same colors. What happens instead is our mate over here, right, is trying to throw to our friend over here. And what happens is they have that wall up in between them. But as he throws the box, right, so we've got that box there, and he's thrown the box over the top. He doesn't even wait to ask Jamish, hey, did you receive it? He just keeps throwing. And next thing you know, Jamish has all these boxes coming at him left, right, and center. He's got more boxes than he knows what to do with. Unfortunately, they're not full of money. They're full of just random stuff that he doesn't really, he can't go and buy a mansion with it or anything. Otherwise, he'd probably be pretty excited, right? But roughly, that's the difference. TCP is connection orientated, while UDP is not connection orientated. So with that in mind, we'll now go into the notes, and hopefully just without all those words coming at us, that should maybe help us out a little bit. So TCP and UDP are two foundational transport layer protocols that facilitate data transmission across the internet. Here's the key, guys. As I was saying, TCP establishes a reliable connection through a handshake mechanism that ensures every data packet is received. However, UDP operates without establishing a connection, right? So why would you want to establish a connection? Probably because you're sending important data that you really can't afford to lose, right? If it's important, if it's confidential, if you just want to make sure it all gets through exactly as it should. So here's exactly how it works, right? So as we said, it is a connection-orientated communication. What it does is before they even start throwing things, they go through a process known as the three-way handshake. And it involves an initial synchronization signal, which is called SYN. S-Y-N, SYN. That's the first step, which is then followed by an acknowledgement, SYN-ACK, and a final acknowledgement to confirm that both parties are ready to communicate. So basically, long story short, guys, what you need to know here is TCP, before they start, they perform a handshake. One device will send SYN, and then the other one will send SYN-ACK, and then the other one will send ACK. And this is just their way of saying, hey man, are you ready? Yes, I'm ready. Let's communicate. Okay, cool. Let's do it, right? We're going to make sure we receive the data. We're going to confirm it before I send the next one. All right. And this results in reliable data transfer, which is really important. It prioritizes security and integrity of the data. So we're making sure all the data gets through. Some common use cases or some examples might involve email transfers. You don't want to get half an email, right? File transfers. Really any application where retransmission of lost data is far preferable to experiencing even a slight error in communication. So, right, if you want to make sure all the data gets through, you'll use TCP, which might leave us thinking, when would we want to not have all the data get through? Don't we always want that? No, not necessarily. UDP, or User Datagram Protocol, is connectionless. So it does not form that connection, okay? It does not form that connection. So what does that mean? Why is that good? It could be good because it has low latency, right? The time it takes to confirm that connection, that last packet has been received, the last piece of data has been received, takes time. And there are certain cases when you just don't have that time, right? So when we think about when you might want to use that, you might want to think about where speed is more critical than guaranteed delivery. So for example, if you're streaming a movie or a video, sometimes you'll notice, oh, it just skipped a couple of frames. That's probably because the data wasn't necessarily received as well as it should have been, but you don't want the whole movie to freeze and stop and like, oh, go back. No, you want a seamless experience. So you'd rather it miss a couple of frames and it keeps going. Similarly, if you've got voice over IP, if you're on a voice call, an internet-based voice call, which is what voice over IP is, or VoIP, then you don't want the person on the other end to freeze and stop talking while you go back and try to get the last data. And now there's like lag between, you might miss a couple of syllables of what they said, but the speed's going to stay put. It's more important to keep that speed up and that latency low than it is to make sure you received everything. Okay. Or online games, right? Things to that effect. Real-time streaming type situations is when you want to use UDP. All right. So you'll need to know TCP versus UDP and when you'd want to use each. Okay. Now let's go ahead and get into some questions. Okay. Some questions, see how we're going. The first question reads, you are an IT support specialist monitoring your corporate email server activity. Let me start again. It's late at night, I'm after work, and my brain is shutting down on me. The question reads, you are an IT support specialist monitoring your corporate email server's activity. You notice that an email client on a user's computer is synchronizing messages directly on the server rather than downloading them locally. Which protocol is being used in this scenario? Is it A, SMTP, B, IMAP, C, HTTP, or D, POP3? Pause the video if you need more time. Getting to your answer in 3, 2, 1. Here it is. It is B, IMAP. That is the email protocol we use when we're receiving emails if we do want to synchronize. Pause and read this if you want, guys. I'm not going to go through all this super in-depth because it's largely what I went over already. I'm just testing you on it now, okay? You can always pause, go back if you want to read the whole thing. Now, the next question reads, you are troubleshooting a network configuration issue at a busy campus. As new devices connect to the network, they automatically receive their IP addresses without any manual intervention. Based on these observations, which protocol is being described? A, DNS, B, DHCP, C, LDAP, or D, HTTPS? Pause the video if you need more time. I'm going to go ahead and jump to the answer right about now. The answer is B, DHCP, Dynamic Host Configuration Protocol. So again, guys, this is the one when you connect to a new network, the DHCP server is what provides you with your IP address. Okay, that is the one. Pause and read the rest of that information if you want to. I'm going to move on to the next question. Okay. Next one reads, you are providing technical support for remote employees who need to access their office computers through a graphical desktop interface. While monitoring the network traffic, you notice that the connections for these remote sessions are being established on a specific port. What port is typically used for this service? Pause the video, read that again. I'm going to go to your answer. 3, 2, 1, now. The answer is C, 3389. So that is Remote Desktop Protocol, or RDP, right? If you want to access someone else's desktop remotely, you're going to be using port 3389 or Remote Desktop Protocol, otherwise known as RDP. All right, pause the video to read the rest if you need to, if you got it wrong, if you want to explore the other answers. But guys, I'm going to go to the next question. The next one reads, you are the network administrator for a high-profile digital conference where hundreds of participants join simultaneously for a live video and audio presentation. In this conference, ensuring a smooth, real-time transmission of media is crucial for effective communication. Which protocol would you choose for streaming the live session and why? A, TCP, because its connection-oriented design confirms every packet's receipt, ensuring reliable delivery even if it introduces additional latency from acknowledgements and retransmissions. B, TCP, because its built-in security features guarantee that all media streams remain encrypted and error-free, perfect for high-security events. C, UDP, because it guarantees packet delivery by retransmitting lost data, ensuring that every video frame and audio sample reaches the participants reliably. Or D, UDP, because its connectionless design allows for immediate packet transmission, minimizing latency for real-time communication despite the risk of occasional packet loss. Boy, that was a lot of words. Pause the video if you need more time. We're going to get to the answer in 3, 2, 1. It was D, UDP. Its connectionless design allows for immediate packet transmission, minimizing latency for real-time communication despite the risk of occasional packet loss. So guys, just again, TCP is connection-oriented. UDP is not. Less security with UDP, but it's better for real-time streaming events. TCP is better for sending information that you really need all the information to get through. You don't want to not have that information. Now guys, I got good news for you. I got a free practice exam. The link is in my description below and in the pinned comment. Click that link. It is a completely free practice exam. All right. You can just go there. You'll just have to create a login and log in, and then you can download the free exam. You've got some performance-based questions there. I haven't put the actual question in here. This is just the screen where you have to sort it out. And you've also got 90 multiple choice questions. So you got, I think it's 3 performance-based questions, 90 multiple choice questions, accurately covering the exam objectives to the same proportion that they are in the exam. Okay, so it's a pretty realistic experience of what you can expect on your exam. And look, everything in my videos that you've seen so far is all from my learning guide. So if you want to go ahead and just grab my learning guide, it's 55 Australian dollars for the learning guide, and it's 80 Australian dollars for the ultimate learning guide, which also contains interactive troubleshooting simulations. But with the learning guide, guys, you get the learning guide, you get 3 full-length practice exams, which is these questions you've been looking at in a randomized format with performance-based questions as well. 90 multiple choice questions, 2 to 3 performance-based questions, and you get three of those in the practice exams. And you also get a spreadsheet to track your results. And if you want the ultimate learning guide version, you get the interactive troubleshooting simulations, and you also get a video on conquering multiple choice questions as well. Just throwing some extra stuff in there. All right. People already in the old one that I did back when I first started this channel, people are telling me, hey, my old resources helped them pass their exams. And here's the thing, guys. This one that I've done, I've like taken what I used to have and I've put it on bloody steroids. All right, it's just out of control. So the learning guide, I break everything down by exam objective, and you can actually click on the specific dot point that you want to have a look at. You get notes, multiple choice questions, detailed answers, performance-based questions. You've got 11 performance-based questions in total, okay? And I also do a video on how to use 2 free AI tools to supercharge your learning. All right. So if there's something that you're particularly stuck on, I actually show you exactly how to go about using 2 free AI tools to conquer those exam objectives that you're a little bit stuck on. All right. I really guide you through the process. So I'm pretty much holding your hand through all of this in this, guys. And in the introduction video, I give you a specific method on how to go about answering or using multiple choice questions to make sure you're actually prepared for your exam. What most people do is they'll go in there and they'll basically just say, oh, yeah, they'll basically just say, where's my nice big green one? They'll just say, oh, yeah, I guess that's it. They'll say, yes, I'm ready for the exam. That's the right answer. I got it right. But they're missing out on the opportunity. I show you exactly how you should use multiple choice questions to actually study effectively. And that's just a bonus on top of the learning guide and the other stuff there, guys. So look, if you like that, it's been a pleasure having you here today. Go ahead and grab it. I can't wait to guide you through your A+ 220 1201 exam. I'm tired. It's late. It's after work. I'm going to go ahead and eat some dinner. Good stuff studying, guys. Good work. I'll see you in the next video, and you are 100% going to pass that exam. Trust me. I believe in you. If I did it with no IT experience, you can do it too, right? See you guys. Have a good one.